54. This stuff's fun. I love this. Okay, so in this one we are going to expand x minus 2 to the fourth power. Now if you notice, this is no calculator. Okay, so there's what we're going to be doing is basically figuring out if I multiplied out x minus 2 and I FOILed it out and I kept multiplying it out over and over and over and over and over again, we're going to see what our resultant term would be. Okay, so what we're going to end up with is we're going to use the binomial theorem. Okay, so since this is a power of 4, okay, all of my exponents as I move along the terms are always going to add up to 4. Okay, so I like to start setting up my terms first. And one thing I always remember is I need one more set of numbers than is listed there. So I'm going to need 5 of each. All right, so I've got x and negative 2. Well, that's 1, 2, oops, 3, 4, and 5. Okay, the powers are going to start with x is going to start from 4 and work its way down. And the negative 2's start on this side and go from 0 to 4, or, so they vice versa. Now, to get the coefficients, we're going to be using our 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Okay, so if you notice, this is a non-calculator question. Okay, so this guy in here, our combinations, permutations here, you cannot use a calculator for them. So there's a few ways that you could figure this out. Okay, for one, you could sort of, kind of do it the long way, kind of doing your combination. You could say, so for example, the 4 choose 1, I could say I could use this. And I could do that for each one. So I could have 4 factorial over 1 factorial, 4 minus 1 factorial, and figure that out. So let me evaluate that one. And then you could do that on all 5 of these. So for this one, for example, I would have 4 factorial over 1 factorial, 4 minus 1 factorial, which is that kind of, we can ignore that. So 4 times 3 times 2 times 1, and 3 times 2 times 1, the only thing I'm going to have left is 4. So this coefficient here would be a 4. Now you could do that for every single one of these terms, which to me seems like a lot of work just to get a coefficient. And I can't use the calculator, so I can't use the combination button on the calculator. So there's one other thing that you guys learned that is pretty quick and easy, and maybe some of you guys have memorized some of the lines, but it's called Pascal's triangle. Pascal's triangle starts with the row 0, and it starts with a 1, and then you carry them down. So this is row 1, and then the way you get each term is you keep adding 1s down the side, but you keep adding up the terms like so this is going to be 1, 2, 1, so this is row 1, this is row 2. So I'm going to add a 1 on the end. 2 and 1 make 3. 2 and 1 make 3. I'm going to add a 1 on the side. This is row 3. And I only have to go one more row. So I'm going to add another 1. This is 4. This is 6. This is 4. And I add another 1. So the fourth row gives me 1, 4, 6, 4, 1. And if you notice, we did the second one here. We did the 4 choose 1, which was 4. So it's just the same way it's just a different way to get the same answer. And to me, making up a Pascal triangle real quick is a lot faster than doing all those combinations by hand. But that's totally a personal preference. You guys can, choose either one. But for me, it was definitely faster to just whip out a Pascal's triangle real quick and some scrap paper, and boom, I've got all those coefficients. So this guy using Pascal is 1, 4, 6, 4, and 1. So I know that part of the coefficients. Now we're going to simplify everything else. Okay, so this is going to be x to the 4th. Negative 2 to the 0 power. Anything to the 0 power is 1. Okay, now I've got x to the 3rd. And then negative 2 to the 1st power is negative 2. Okay, plus next term. X squared. Well, negative 2 times negative 2 is positive 4. So watch out for this negative because my signs are going to keep alternating. Plus. Next one, okay? Just have one x now. And negative 2 times negative 2 times negative 2, it's odd. So this is going to be negative 8. Anything to the 0 power is 1. And negative 2 times negative 2 times negative 2 times negative 2, it's basically taking this negative 8 and multiplying by 2 one more time, is 16, positive. So if you'll notice, I have positive, negative, positive, negative, positive. So and that's always going to happen whenever you have a negative term there for your second term. All right, so the last thing I need to do now is just clean it up. Okay, term 1, 1 times 1 times x to the 4th. This is just x to the 4th. Okay, next term, I've got 4 times negative 2, that's negative 8, and x to the 3rd. And my power should decrease as I go down the list. Okay, next one, I've got 6 and 4, that's 24, x squared. This one should be a minus. It is, right? 8 times 4. And then the last term should be positive, 1 times 1 times 16. It does not want me to make a box for some reason. And there is my final term. Okay, the next one. What is the coefficient of x to the 3rd in this expansion? Okay, so, all right, what we're going to figure out is I'm going to kind of start this one off kind of the way I started off the last one. I know that I have, this is 5, so I know I need 6 of these, and hopefully I won't need to make all of them, but I know I'm going to have x and 2, x and 2. This is going to go 5, 4. Remember, I'm looking for x to the 3rd. Right? And actually I can stop because I found the x to the 3rd term, so I know that the x is going to have a power of 3, but what would the power of the 2 be? Well, if you take a look, let me flip back to the last problem for a second. All of these always had to have a sum of the original power, right? 4 and 0. So we're looking for what's going to make this sum, oops, sorry, too far. Way too far. We're looking for what's going to make that have the sum of 5. So if my x term is a 3, that means my 2 must have, my base 2 must have a power of 2. And then these two, and then that actually makes sense because then this would be a 1 and then this would be a 0. Right? So does this make sense that this is the right term? Now the other thing that we need is what is the combination in the front? Because now I know I have this. Right? Now I know I have this. And what is the combination in the front? Well, the top number is always going to be your power, your lead power. And the bottom number always comes from the second exponent. So 5, choose 2. So again, this is a non-calculator. So I'm probably going to evaluate this. You can do it one of two ways. You can do combination by hand, or you can pick up with your Pascal's triangle that you did on the last problem, just make one more row. So I'll show you both ways. If you're going to do combination, this formula is on your sheet. Okay, so let me just simplify this. Okay, and then let me expand this. 5, 4, 3, 2, 1. All right, let me 3, 2, 1. This cancels with this. The 1 doesn't matter, so I end up with 10. Okay, so here's how to do it by hand. If you want to do combination, I get 10 x to the 3rd. What is 2 to the 2nd? That's 4. These two multiply together to make 40. So the term is 40x to the 3rd. It asks for what is the coefficient. The term in front, 40, is the coefficient. Okay, so what if you're looking at this and going, no way, that's too much. Well, the other thing you can do is, again, I'm just going to flip back to the last problem. Remember we did Pascal up to number 4? If you just bring it down one more, 4, these add to make 5, 10, 10, 5, and 1. So here's row 5. And we were looking for the third term. 1, 2, 3, right? Look at that, it's a 10. So we could have got it from that. So, you know, Pascal's triangle takes a minute to make, and, you know, sometimes makes your life a little easier if you want to give it a try. Okay, what's the coefficient of the x to the 9th y term? Of x to the 3rd, I can't see this, sorry. Let me write it over here because the timer here is in my way. Okay, and you could be looking at this one and saying, hey, wait a minute. This is they're supposed to have a sum of 4, and I don't understand why this guy has a 9 in it. Okay, but let's take a look. We're going to start this off the same way, right? We know that the big power is a 4, right? So I'm going to have x to the 3rd, 5y. X to the 3rd, 5y. X to the 3rd. And there's 4, so I'm going to need 5 of these. 1, 2, 3, 4, and one more. Okay, now let's fill in the powers. 4, 3, 2, 1, and 0. And 4, 3, 2, 1, and 0. Look at your power to power operations, right? This is actually going to be the x to the 12th. So if we're looking for x to the 9th, I'm looking for, well, where is it, you know, where am I going to get a 9 on the x coefficient? And if you look, it's actually your second term right here. 3 times 3. And look at your y. This is a 1. So this is the winner right here. I've got x to the 3rd. Oops, sorry. To the 3rd and 5y to the 1st. Now the question is, what is the combination in the front? The power is 4, and this is term 1, right? It's 0, 1. So on the Pascal's triangle, or again, you can do it by hand if you want to, but let me go back. Pascal for second term is a 4. So I get this right away. So I get 4, x to the 9th, 5y. So 4 times 5 is 20. So what is the coefficient? The coefficient is 20. Okay. And last one. Okay. I know this video might be a little long. I hope it uploads okay. Last problem is, what is the distance between the point and the line? Okay. All right, on this one, you have a formula sheet. It's on the very front of your formula sheet, and it is this formula that you're going to be using. That is absolute value there. Okay, so what we're going to do is we've got an x and a y, and we've got an A, a B, and a C. Okay, and it looks like that's, you know, everything we need. Like, look at the formula. Like, I need an A and an X, a B and a Y and a C, an A and a B. We've, you know, they're pretty much giving us everything. So let me go ahead and start plugging in. All right, in my numerator, I have A, which is 3, times the X coordinate 2. Plus B is negative 4, times the Y coordinate, negative 3, plus C, which is 12. And we're going to ensure that that comes up to be a positive number. Over my A squared plus B squared, so 3 squared and negative 4 squared. Okay, and this is a no calculator question, so that's important to keep in mind. Okay, so let me simplify this a little bit. The numerator here, this is 6. That's 12, and that's 12. Okay, this is 9 and 16, and together that makes 25. Okay, Well, square root of 25 is 5. And I don't really need to worry about these because this is going to come out to be a positive number, so I think I'm good to go. And let's see, 12 and 12 is 24. And another 6 is going to give me 30. And so my final answer, how many times does 5 go in 30? 5, 10, 15, 20, 25, 30. 6 times. So the distance between the point and the line, it would be 6 units. Right? They're 6 units away from, the point is 6 units away from that linear function. All right, and that's it. I hope you had fun, folks.